Hey everyone, today we're going to finish out part 1 of the cardiovascular system where we're talking specifically about the heart and the cardiac cycle. So today we're going to learn about cardiac output, which is abbreviated CO. Cardiac output is defined as the amount of blood pumped by each side or each ventricle of the heart in 1 minute. To find cardiac output, this is the product of heart rate and stroke volume. So product is your multiplication. So now let's define those two parts that affect cardiac output. Stroke volume, which is abbreviated SV, is defined as the volume of blood pumped by each ventricle in one contraction or one heartbeat. This is about 70 milliliters of blood, and so about 70 milliliters of blood is pumped out of your left ventricle every time with each heartbeat. Heart rate is abbreviated HR, and we've kind of mentioned this before. Heart rate is how many beats that your heart beats per minute. So this is typically around 75 beats per minute for a healthy average adult. Now it can run lower and it can also run higher depending on any health conditions you have and how in shape you are. So cardiac output, again, is the product of heart rate and stroke volume. Again, if we were to find the average cardiac output for a healthy adult, heart rate is around 75 beats per minute. Stroke volume is 70 milliliters per beat. So when we actually multiply those two values together, you get 5,215 milliliters per minute, or if you want to change it to a volume that's even bigger, 5.25 liters per minute. And this is where I kind of brought in that fun fact for you guys the other day. A normal adult blood volume is about 6,000 milliliters, or about 6 liters. So nearly the entire blood supply passes through the blood each minute. So once each minute. Imagine that. Okay. So now that we've kind of talked about factors that go into cardiac output, how is cardiac output changed by these different factors? So we're going to first learn about the regulation of stroke volume, or what happens when stroke volume changes. 60% of blood in ventricles, and this is about, again, we said 70 milliliters, is pumped with each heartbeat. So that's a weird number considering 60%, but that's actually a pretty good percentage of blood that we can pump out. And then there's something known as Starling's law of the heart. So the critical factor controlling stroke volume is how much cardiac muscle is stretched. The more the cardiac muscle is stretched, the stronger the contraction is going to be. I like to think of this as like a rubber band. If you stretch a rubber band a little bit and then try to shoot it off, it's not going to go very far. But if you take a rubber band and you stretch it as far as you can and then let it go, it's going to have a stronger fly. It's gonna fly better. Same thing with the heart. You have to get it stretched out. It's like a spring in a coil. So then when it's released, it's able to contract and push that blood to the rest of the body. So venous return is actually a very important factor influencing how much that heart's going to stretch. So if you don't know what venous return is blood returning to the heart. The more blood that we can get back into the heart, the more that heart is going to stretch because it's got more blood to fill it, and the more that the heart is going to attract. So venous return, again, is the amount of blood entering the heart. So anything that increases the volume or speed of venous return actually increases your stroke volume and how much that contraction is forced. Exercise speeds up venous return because your heart's pumping more, so your blood's able to get through your body faster and return to your heart. However, low venous return is something that can result from if you have blood loss. So you don't have as much blood returning because you're losing it, or if you have a slow heart rate, because your heart's not beating as much blood, it's doing it a lot slower. So that means it's filling slower before it's able to beat. So here, low venous return results from severe blood loss and slow heart rate. And again, that's going to decrease your stroke volume. Now, if we look on the other side, instead of looking at stroke volume, here we're going to look at basic things that affect heart rate. Well, some of these things you've heard before. We have neural controls, and your neural controls is your ANS, or remember ANS equals your autonomic nervous system. So your sympathetic branch of that nervous system helps speed the heart rate up, whereas the parasympathetic, primarily through your vagus nerve, actually slows and steadies the heart rate and slows it down when you're resting. The second thing that can affect heart rate is hormones and ions. So epinephrine and thyroxine help speed up the heart. Again, remember epinephrine and hydroxines are these hormones that can be sent through these neural pathways. So your sympathetic nervous system can secrete epinephrine to get your heart going. Also, ions, if you have an excess or lack of different ions, are important for nerve impulses in cardiac muscle, such as calcium, sodium, potassium. These are all going to change your heart activity and the speed of your heart rate. And then last but not least, we have some physical factors. Age, gender, exercise, even your body temperature can influence how fast your heart's beating. So if we're going to look a little bit deeper into that specific category, heart rate is fastest in a fetus, and actually it gradually decreases throughout life. If you've ever seen a video of a sonogram, it sounds like a butterfly flying because the heart rate is so quick. But then again, as you birth, you get into a toddlerhood, you become a teenager, you become a young adult, it's going to slow down. Now, heart rate is faster typically in females than it is in males. The average for females is 72 to 80, whereas in males, it's about 64 to 72 beats per minute. Heat also increases heart rate. So when you're hot, think about even when you're hot, when you exercise, your heart's beating faster. And when you're cold, this is going to decrease heart rate. And then exercise increases heart rate as well. So here, I love this picture because it kind of helps explain things that affect cardiac output. So anything that is boxed in red is your initial stimulus. Anything that is boxed in green is just a response. The arrows are going to indicate something a little bit different. If it's a green arrow, it's going to increase. And if it's a red arrow, it's going to decrease. So notice here we talked about if you decrease blood volume or you have a hemorrhage or a bleed, that's going to decrease your venous return. That's going to decrease your stroke volume, which again decreases cardiac output. Over here, we talked about hormones like epinephrine. That's going to increase your contractile force and also increase your heart rate, which again is going to eventually increase your cardiac output. Over here, it says crisis past. So while there's a crisis, it's going to increase and tell your parasympathetic nervous system to work, and your parasympathetic nervous system is going to decrease your heart rate, which is going to decrease your cardiac output. So this is a pretty good flow chart to help what is going to affect and what's not going to affect cardiac output or speed up and slow down. So that's the end of today's lesson. Let me know if you have any questions, and I hope you guys have a good day.